Sample preparation for the analysis of environmental pollutants. The integrity of sample preparation for the analysis of environmental pollutants is of paramount importance and has to be addressed seriously with the utmost care and attention to the methodology and its quality. The environmental sample residue presented for analysis by GC or LC and in combination with mass spectrometry must reflect the original sample matrix in terms of the concentration of the pollutant present. Hazardous pollutants need to be detected and quantified at ultra-low levels, approaching the limits of detection of the instrumentation. This talk will consider the methodology involved, progressing from the environmental matrix sample to the environmental pollutant residue, ultimately to be analysed and quantified. Commencement of analysis of environmental pollutants in complex matrices stems back to 1976, when US-EPA were analysing hazardous waste. GCMS was selected as the instrumentation of choice using a packed column jet separator between the GC and MS, basic data system, and low-resolution magnetic sector or quadrupole mass spectrometer. The initial analysis demonstrated that injection of a sample without pretreatment to remove intractable substances was useless, causing desensitization of the mass spectrometer ion source and loss of chromatographic resolution in the packed column, GC. Initially, 1,500 pollutant compounds were identified, of which 129 were identified as being of hazardous significance, subsequently termed as priority pollutants. At the outset, it was realized that sample preparation was required depending on the nature of the matrix, involving sampling, extraction, cleanup, and residue formation by volume reduction. Analytical methodology, sample treatment and workup. Clean matrix samples, potable reservoir and river water, etc., require sampling, extraction, and volume reduction. Sampling techniques can be quenchers or affinity discs. Extraction can be liquid-liquid extraction, solid phase extraction. An online technique, SPEMI, allows direct injection of the sample residue after absorption on a C18 absorbent. Solid matrices, sediment, flora, fauna, sludge, other industrial solids, which require considerable workup prior to obtaining a suitable sample for analysis by GCMS. Techniques for solids, steam distillation for pollutants with a finite vapor pressure, or soxylate, microwave, or ultrasonic extraction. Cleanup is required to separate non-polar or polar substances which may interfere with the chromatography and mass spectrometry. A range of cartridge substrates are available to remove interfering substances ranging from non-polar to polar depending on the functionality of the substances to be removed, exemplified by C18 methyl for non-polar to C18 amino or fluorosil for polar interference. Note: several cartridge types. C18 methyl can also be applied to isolate the target pollutant for which the matrix is relatively free from interfering substances such as potable and river water. Note also, drastic action may be required to work up samples containing dioxins, such as treatment with concentrated sulfuric acid to remove hydrocarbons from the initial waste. Special techniques. Less volatile or non-volatile substances can be analysed if the functionality present with active hydrogen is converted to an inactive state, for example, for phenols, amines, and carboxylic acids. Derivatization can enhance the response in several ways by increasing the volatility, leading to a decrease in the width and tailing of the chromatographic peak, thus increasing the detectability and sensitivity, also by introducing an electron-affinity group. Derivatizing agents, diazomethane, methyl iodide for methylation, trimethylsilyl TMS, and derivatives for TMS ethers and amines, for alkyl derivatives for introduction of electrophilic groups. GC negative ion chemical ionization mass spectrometry, rather than GC electron impact mass spectrometry, can be employed for which electron affinity groups are introduced, whereby the associated electron capture process would generate an anionic fragment, often identified with the fragment of the original polluting molecule, e.g. phenols represented by ROH. The reaction, pentafluorobenzoyl with ROH, gives ROPFB, and ROPOB in the mass spectrometer ion source undergoes dissociation electron capture via an intermediate, which leads to RO-, indicative of the molecule, and PFB+. Quality of analysis. Reference standards are required for pre-calibration of environmental pollutants to obtain relative response factors to ensure the quality of the analysis, and isotopically labeled analogues for or internal standards of the target analytes, e.g. C13 labeled, are added at the initial extraction stage. The equation on the left-hand side is for the calculation of the relative response factor by considering the plot of area for the reference compound versus area of the volumetric standard multiplied by the concentration of volumetric standard over the concentration of the relative compound. The graph on the right hand side shows the linearity of this plot and enables the calculation by extrapolation of the concentration of the extract. At the volume reduction stage, volumetric standards are added to ensure the final made-up volume, 1 ml, is reproducible and representative of the extraction. Therefore, from the graph, we can see that the concentration in the extract is equal to the x value by extrapolation to the base line, x-axis, times the concentration of volumetric standard. The units, milligram or microgram per litre, or milligram or microgram per kilogram. The original concentration in the liquid or solid matrix is equal to the concentration in the extract times 1 over CF, where CF is the concentration factor, typically 10 to the 3 for liquid and 50 for solid matrices respectively. Absolute recoveries of pollutants can be obtained by reference to the recoveries of the isotopically labeled internal standards, with quality control of prime importance, ensuring that the analytical methodology is sound and is well founded. Very many thanks for your attendance.